Now we're asked to sketch a triangle so that this statement is true. Cosine of theta is equal to the square root of 3 over 2. And we want to make this as easy as possible. So let's just draw ourselves a triangle. It doesn't have to be perfect. We're going to sketch it out. We'll start with a straight line. And what I would like to do is I'd like to make sure that as I draw this out, it'll be a right triangle. So I'll draw a couple intersecting lines. They intersect perpendicularly. And what I want to do is draw it so the hypotenuse and the adjacent side are represented right here. Now I'll just draw a little arrow. Cosine is the adjacent over the hypotenuse. So as I place this angle, theta, in my picture, I want to make sure that the side adjacent to it is the square root of 3 and the hypotenuse is 2. There we go. We have a little sketch. Don't worry, it doesn't have to be perfect, but I do have the theta. Cosine of theta is equal to the adjacent. So here's my adjacent side. Just draw a little arrow to it. This side right here is the adjacent side, and it's the square root of 3. The hypotenuse, well, that's the longest side right here, and that's equal to 2. And so it looks like this. So we've got a nice little triangle. And now you say, that looks familiar? Yeah, it does. Perhaps you recognize it, and maybe not. I'm going to call this length here y. I can call it a whole bunch of things, but let's use our Pythagorean theorem. We have this length here y, which we don't know what it is, hypotenuse of 2, and the adjacent side of the square root of 3. If you see what this is, write it down right away. If not, let's investigate. A squared plus b squared is equal to c squared. Now we'll just solve that for y. Square root of 3 squared is 3, plus y squared equals 4. Subtracting 3 from both sides, I get y squared equal to 1. Taking the square root, y was 1 all along. Now that we know this, that y is equal to 1, we have the length of our triangle, and we could actually write out our trig functions. Let's give it a go. Sine of theta, cosine of theta, tangent of theta. Let's start with this. Now cosine of theta was given to us, which is the square root of 3 over 2. Sine of theta is the opposite over hypotenuse, 1/2. I bet you recognize what that theta angle measurement is right now. Tangent of theta is y divided by x, or sine divided by cosine, which we would have 1 over the square root of 3. Now let's go find our reciprocals. Cosecant of theta is equal to 2 over 1. Secant of theta is equal to 2 over the square root of 3. Cotangent of theta is equal to the square root of 3 over 1. Look at how much information we can get from one little statement, cosine of theta, and now we know all of this other information. So did you figure out that theta yet? I bet you did. But if you didn't, let's take a look at our calculator. there's an inverse cosine feature where we can type in what that ratio is. In this case, the square root of 3. I have to arrow over now because I want to say divided by 2, and I don't want that underneath that radical symbol. Now what this will do when I hit enter, it's going to give me the theta measurement. So I'm going to put a little note on here. I think this is very helpful. Let me write this note so it really stands out. Note, if you want to find theta, let's just take this information right here. We want to find theta. We could say theta is equal to this inverse cosine of the square root of 3 over 2. Now writing this out is very helpful. Let's go ahead and enter that. It is 30 degrees. That angle measurement was 30 degrees all along. Now we could certainly check to make sure. Sine of 30 degrees is in fact equal to 1/2. How about tangent of 30 degrees? Tangent of 30 degrees is equal to 1 over the square root of 3. I better check because 1 divided by the square root of 3 is the answer I came up with on my handwritten work. When I use the calculator, I come up with this decimal approximation, and I just want to make sure that they're the same value. Looks good. Alright, you said that one was too easy. Well, let me try another one. I'll just clear this out. Now it says sketch a right triangle where tangent of theta is equal to 5 divided by 6. So let's give that a try. There we go. I have two perpendicularly intersecting lines, and I'm going to draw some triangle in here. Let's go, I don't know, something like this. There we go. Now let's see where to put theta. Now I put theta right in here because I thought it would make drawing the triangle pretty easy. Because I know tangent of theta is equal to the opposite over the adjacent. Now that's why I chose this to be 5, because it would be opposite of theta. And I chose this to be 6, because it would be the side adjacent to this angle. Now we haven't identified the hypotenuse, but we're going to do that now. We'll call it C again. You liked that last time. So we've got a squared plus b squared is equal to c squared. So I have 36 and 25 that sum to 61. And so c is equal to the square root of 61. Probably pays to write it down here like that. Well, great. I think we're good shape now. Let's write out our trig functions. And I encourage you to do it in this format: sine, cosine. Sine is the y-coordinate. Cosine is our x-coordinate. So it's an easy way to keep track of it. Now, certainly I didn't draw the unit circle here, but sine of theta is equal to the opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. Tangent of theta was given to us as 5 over 6. We see that's true for this statement as well. Find the reciprocals. Cosecant of theta is the reciprocal of sine of theta. Square root of 61 over 5. secant of theta is equal to the square root of 61 over 6. And cotangent of theta is equal to 6 over 5. Now we look at, well, I wonder what that angle is. Let's see if we can estimate it. If this was a 6 right here, it's not, it's a 5, but if it was a 6, that would be a right isosceles triangle, in which case this would be 45 degrees. That is if it went up a little higher here. But it doesn't go up that high, so it's a little less than 45 degrees. Let's find out what it is. Let's pick our favorite function out of here. This time I'm going to pick sine as my favorite function today. And if I want to find what theta is equal to, let's put a little note over here. Note, let's write this out. Theta will equal the inverse sine, also known as the arc sine, of 5 over the square root of 61. I don't know what that's equal to, but I know it's less than 45 degrees. So let's enter this into our calculator. 5 divided by the square root of 61. Looks like this. Now here comes that angle measurement. We knew it was less than 45 degrees. It looks like theta is about 39.8 degrees. Just a little note. This will be helpful in the future. Now for fun, let's try that. Sine of 39.8 degrees. Now notice that I'm doing some rounding. I rounded to 1 decimal place. So when I hit enter, I get 0.64. And that's going to be close, but not exactly the same, as 5 divided by the square root of 61. So you can see that the rounding impacts our answer a little bit, but for a lot of practical purposes we'll need to round this somewhere.